Okay, we're back here. For those of you who are watching this on tape, let me say that I obviously had to divide on the syllabus. I needed to divide by 2 weeks for this and 1 week for this, et cetera, but it doesn't quite work that way. You see, I'm going into the next topic already. I did it for convenience sake, so I wouldn't have to say, well, 1 hour and 2 hours and 17 minutes on this. But if you're watching the tapes, be sure that it's not going to be that neat and sweet, so you're going to have to watch. This tape is actually the beginning of what I'm talking now is what's listed for next week. I knew it would happen, but that's how it works. Okay, I want to tell you about what I call one of the great divides in psychology between theory and practice and not coming together. And I think how their failure to come together has worked to the detriment of children and adults for a long time. The story begins in France with a man whose name was, let's go to the overhead, Binet. Alfred Binet. Does this name ring a bell with anybody? What does it ring the bell?
Intelligence test.
Put it down.
Intelligence
That's
testing.
it. The Stanford Binet intelligence test. Binet was actually commissioned. Okay, come back to me. Binet was commissioned. It was either by the government of France or the government of Paris. I think it was France. To devise tests to determine what children would benefit from schooling in France, and for what children would it be just a waste of time. Today, we say everyone has a right to an education, but in those days, basically, they said, we have a standard curriculum, we want to see what to do. So Binet began to devise these tests. And let's go to the overhead. To the PowerPoint. What he did, whoops, I messed this up. What he did was he devised his principle of comparison to the norm, what we call age norms. Okay. He took each child's performance on various skills or tasks, and he tested how well they did compared to the norm for that age. Okay, so come back to me. So in other words, what he did was something very interesting. He took a whole bunch of tasks and he gave the same task to children of various different ages. Okay, he didn't care. And what he said is, let's see how well you do on this test compared to other children your age, right? So we had one task he would expect, we said, well, right? Here's this test, and the 6-year-olds got about half the questions right. The 9-year-olds got 3/4, and the 12-year-olds got virtually all of them right. Okay, he didn't care. Then he said, okay, so let me see how well you did compared to other people your age. It's a principle of comparison to the norm or age norm. So if there are 20 questions and the average right for your age was 10 and you got 12 right, you did well for your age. If you got 9 right, you did a little worse for your age. And at some point he had a cutoff. He said, look, anybody who got 3 or less right, this person probably is not going to benefit from school. I'm just making up the numbers, but you get the point. Okay? Now, if you were given this job by a government to do this, what kind of questions do you think you would ask? In what areas would you ask questions? Or what kind of things would you test? You think you'd test the ability to climb a mountain? Probably not. What would you test? Just tell me off the top of your head what you'd test if I gave you that job. And I'm paying you a lot of money. We'll push it down? Push down the microphone. You don't have a microphone? No. All right, so say it and I'll say it for you.
Analogies.
Okay, maybe analogies, the ability to think, a reason, although he didn't. What else would you test?
Describe.
What?
Describe objects.
Say it again?
Describe some objects.
Describe some objects, yeah. How well you'd notice certain objects and what was right or wrong with them. Description was a little tough because he wanted standard answers. But he did the opposite thing. Here's an object. For instance, one standard thing is an IQ test. Here's an object. Something's wrong with it. Can you see what's wrong? What else what kind of skills would you test? You're testing kids who have been in school too. Yeah?
Language skills.
Yeah, language skills. What else? What else would you test? You're testing how the kids benefited from school. You got kids in the 5th grade. You want to see if they benefited from school. What would you test? Go ahead.
Math.
Math. What else? Yeah. General knowledge, maybe, right?
Reading comprehension.
Reading comprehension, that kind of stuff. Although, again, reading comprehension was tough because you have to have standard answers. But, right, that kind of stuff. So
what about writing?
The good question. A good question. The answer is yes, I would, but no, he didn't. Okay? Because writing's tough. Then you can't just run it through a computer, or you can't just check off, right? He wanted stuff that could be standardized. And by the way, that has come. Tell me your name again? George. Push it down.
George.
Right. George has actually brought up a vociferous objection to these tests. He didn't know it. What about writing? Well, if you write, everyone in this room could write something different, and I could say, oh, they're all good. Right? You know, describe this room. Some people could describe the color. Some people would describe the feeling it makes them have. Some people could describe its uses. They're all good. But then you can't run it through a machine in Austin and test it off, right? Now they're trying to get writing. But a lot of people have objected vigorously to the fact that these tests don't allow any free will or something, right? Any free expression. But in any case, so that's what he did. Now this is based on no theory whatsoever. It's just stuff he cooked up. That's what IQ tests are. There's no theory behind it. It was just his sort of a thing, the kind of kids things ought to know in school. But he was doing something, this was the beginning of the 20th century. He was doing something that no one had ever done before. He was getting consistent answers from lots and lots. He was giving consistent items to lots and lots of kids across age levels, and he was giving the same questions to all the kids. This was something new and exciting, hadn't been done. He had the money to do it. No one had the money before to do it. And this intrigued a lot of people. And a lot of people came to work with him. And of interest to us are a group of people who came from one place and a one person who came from another place. Of interest to us is some people came from Stanford University in the United States, in California. They went up with the Stanford Binet intelligence test. And a young biologist from Switzerland named Jean Piaget. Here, kind of the overhead. Okay. Jean Piaget. We'll run into Mr. Piaget at length later in the course, okay? And these people came. Piaget was sort of interested, he was interested in psychology and the nature of human and development of human intelligence. You'll see it when we get to him. And they were given the job of classifying answers. What age the kid was, how many did the kid get right, how many did the kid get wrong, and putting them in all these categories. That's what the people from Stanford did, and eventually, Binet had one question. Yes, no. Yes, the kid should go to school because she will benefit. No, the kid shouldn't go to school. Let me tell you now why I look at my watch. Little diversion. I probably should have done it at the end of the first section, but I'll tell you now. It doesn't bother me when political movements come along and have their influence on them. So we used to be Mr., Miss, or Mrs. Now it's Ms. It doesn't bother me. You do what you want. I don't care. I'll just go with the flow. Unless it comes to corrupting the English language. That, I draw the line. I was an English teacher for a long time. It used to be, look, everybody is in is. You hear it singular? You can't say everybody is in their seat. Everybody is singular. Everybody is. It's like saying the child is in their seat instead of the child is in his seat or her seat. Right? I did their work instead of I did my work. What are you talking about? It's singular. Everybody is. Is. You hear it? Now, in the old days, when I was young, you were told to use masculine pronouns. Everybody is in his seat. Each child, you can't say each child is in their seat. Child is singular. You have to use a singular pronoun, right? So I was told to say each child is in his seat. Well, along came a political movement. That's not fair. It discriminates against women. I said, fine, doesn't bother me. You have a point. So then we start this. So first of all, we started this. Every child is in their seat, which is horrible, and that's what people do to this day, right? Or each child is in his/her seat, right? Each child did his or her work, etc., etc. Or you don't do it in singulars. All the children are in their seats. Lop off a whole bunch of ways. Well, I'm not going to buy that. Now I have a system. One day I'm reading a book. And the author is using feminine pronouns. Each child did her work, etc., etc. All of a sudden, I come to the second chapter. He's using masculine pronouns. And here's a little note at the bottom expressing some of the sentiments I did, which is I can't get involved in this political stuff. I'm not going to put her/his, he/thee, it's messa. And every odd number chapter, I'm going to use feminine pronouns. Every even number chapter, I use masculine pronouns. Leave me alone. So that's what I do. Every odd numbered day, I use feminine pronouns. Every even numbered days, I use masculine pronouns. I have a hard time when we discuss little children because the only infants I had were males. If you want someone who just slips with the feminine pronouns all the time, take this course from Dr. Gay, who had little girls, and he just naturally says her. Okay? But in any case, I try hard. So that's how it works. Now, it's not completely fair. As it happens, we're recording this course on the 31st of the month, and next month will be the 7th. So we will have feminine pronouns 2 days in a row. So if the males in the class wish to launch a protest about gender discrimination, I will help you finance picket signs. You can pick the class around, but that's how I'm doing it. So today is a her day, right? Now, that's how we do it. Now, and if you have a little hint that political correctness rubs me the wrong way sometimes, you are correct. As a matter of fact, I'm not very politically correct at all, as you already know from what we said before. Now, so the people from Stanford, they came and they did the job that Benet gave them. They organized the stuff in categories, seeing how many people got it right or wrong. And basically, as I said, Benet had a cut. Can this child benefit from school, yes or no? If you're above this line, the child should go to school. If the kid, in other words, if the kid answers enough correct, but if the kid is below this line, she shouldn't go to school, right? In other words, if she got one right and whatever the norm, everybody her age is getting 20 right. You understand what I'm saying? He just made an arbitrary cut. The people from Stanford went back and said, oh, we don't have to do that, just yes or no. And by the way, Benet did not like this. He said, I can compare everyone to everyone else. Right? You got the norm, you got how many less than the norm, and now we'll see how they did it. Okay? But Piaget did something else. He took a look at the answers and he said, now this is not a direct quote, but this is the sentiment of it. How did these kids come up with these cockeyed screwball answers? Where did this come from? Whoever has been with little kids know that their answers are screwball. Oh, okay, well, we'll get to that. Oh, yeah. My son once asked me, did you know Babe Ruth? I said, no. He lived a long time ago. Oh, did Grandpa see Babe Ruth play? This was the question. I said, no, he didn't, but he could have taken a train to see him play in New York. Oh, could Grandpa take a train and see George Washington? I said, no, that was too long ago. Oh, could Grandpa take a train and see Christopher Columbus? I said, no, too long. Then I remember I couldn't. Did Grandpa take a train and see Moses? That was enough. I didn't want to hear it anymore. Right? I said, no, Grandpa was afraid of trains. I told him something, I don't know. Screwball, cockeyed answers that you get. And it stuff that couldn't, it was just amazing. So he went back and said, something's screwy here. I don't get it. I'm going to go back, and he spent the rest of his life, he called it a diversion in his biological career that lasted 60 years, right? I'm going to go back and try to figure out what's going on here. I'm going to stand up. Okay, ready? I'm standing up. Here we go. And that was what I call the great divide in psychology. Those people who want to know what's going on and those people who want to test. The testing stream is not based in theory. Now, Piaget went and made a theory of why kids think the way they do. There are people who vociferously disagree with him. Those are the theories we're going to discuss. Right? I think he's more right than wrong, but that's just my opinion. Okay? But we have this testing stream based upon testing and comparing to other people on items that come from no theory of thinking, learning, or behaving. They come from nothing other than the kind of stuff that everyone's been doing and the tradition. Okay? And this to me is perhaps, there are many divides that to me this is the great divide. The theory people versus the testing people. And I'll tell you right now, I think that what the testing people have done, they've wrought some terrible things on our society, right? Okay, IQ tests, which are the start of these tests, have had all kinds of problems associated with them. All kinds of, we know, for instance, we'll discuss this later about how they've been accused of being prejudiced against the black population in America, but that's not the first ones. Okay, they've been used to prove the innate inferiority of just about every ethnic group in America that got here after they were devised. If you're from Irish background, you're lucky, because people didn't like the Irish too much, but the tests weren't around, right? They've been used, so these tests have a lot, but there are a lot of more problems. Even on a day-to-day basis today, there are problems with them. So what I want to do, I want to spend time, a lot of time, showing you these tests, and frankly, showing you what I think is wrong with these tests, okay? I can't show you exactly what's on the test because this is broadcast, this is being broadcast, and the tests are a secret, okay? In other words, Mr. Green, excuse me, today's a she day. Ms. Green, your child is retarded. Sister, is your child retarded? Well, can you tell me what's on the test? No, it's a secret. It's a secret. The items are a secret. So you need to know on a need-to-know basis. Well, as far as I'm concerned, people are going to refer kids for testing need to know, and I let teachers see the items on the test, but I can't do it here because it's broadcast on the airwaves. I can't even give you an old one because the tests don't change that much for reasons you'll see. But I will give you examples that are very close. Okay, that are very close when we get there. But first let's go into the logic of this. Okay, let's go back to the PowerPoint. Okay, so each child's performance on various skills is tested the way they work today, since they developed from Binet. I'm talking about modern IQ tests. And a child's IQ is determined by comparing the number of answers she got correct, today's a she day, on the test compared to the average number of answers for her age. Okay? How was IQ calculated? This is the old formula. You got it? There you go. Now you're going to go to the next slide. Okay. Your IQ is your actual age, your mental age, divided by your actual age times 100. So let me show you. Let me show you on here. Okay, let's go to this. Thank you very much. So if a child's chronological age, right, is 7, and the child's mental age is 7, so it's set. Here, I'll write the formula here. Here, IQ equals, right, equals your mental age divided by your chronological age times 100. So it's 7 divided by 7. How much is that? Wait, I'm using my fingers. That's 1 times 100 equals 100. Okay, so you see that? If the kid's mental age is, now if the kid's mental age is, let's say the kid's chronological age equals 7, and the mental age equals, let's say it's 9. Let's say 7, what the hell. Here, 7. I'm just trying to do something I can do in my head. And the mental age is 8, so the IQ will be 8 divided by 7 times 100. Does anybody have a calculator? What's 1? It's 1 and 1/7, or what's 1.7 in decimals? What's 1/7 in decimals? What do you get?
114.28.
So it's 1.14 times 100. The kid's IQ times 100 is 114. Can you see that on the screen? Okay. You get it? That's all. So the big question is, how do you determine mental age? Right? Okay, so come back to me, okay? So we can get this. And I'll get another. Come back to me if you can. Okay. Mental age is determined by the average number right people that age got. Okay? So here, let's go back to the power. Let's say on the whole test, let's go back to the overhead, that 8-year-olds got, I'm just making up these numbers, got 52 answers right. 7-year-olds got 43 answers right. 9-year-olds got 77 answers right. So if you got 43 answers right, what's your mental age? 7, you see? You understand what I'm saying? So let's go back to the formula. IQ equals mental age. These things are persnickety. Over chronological age, right? Times 100. So let's say you're 9 and you got 52 right. What's your mental age? 8, right? How much is 8/9 in decimals? 0.88, so it's 0.89, right? Times 100, so your IQ would be 89. You get it? So if you're, let's say the mental age for 4-year-olds is, the number right is 22, I'm just making that up. And for 5-year-olds is 36. So let's say you're 4 years old and you got 36 right. What's your mental age? 5. You see why? Okay. This one I can do in my head. Okay. So that's 4. It's 1.25, right? Gives you an IQ of 125 because it's times 100, right? You get it? Now what if you got 54 right? So your chronological age would be 8.2, right? You understand what I'm saying? Your mental age would be 8.2 and you plug it in here. You get it right. If you have a calculator, or that's, by the way, come back to me, before uh-oh, we lose something? Can you come back to me, or we got troubles? Before calculators and computers, the people who came to work for Benet spent a lot of their time figuring this stuff out. Well, wait a minute. If you got 57 right, that's a mental age of 8.36 years, right? If you got 76 right, 77 is 9 right, that's a mental age of 8.89 years. I mean, they went through all this stuff and they're dividing, but that was the principle. Okay? That's how it was done. Now, this stuff was problematic for a couple of reasons. Number one, it was hard with adults. What's the mental age of 37 versus 39, right? Oh, there were people who wrote books. They would tell you what Alexander Hamilton's IQ was, what Benjamin Franklin's IQ was, what Newton's IQ was. I mean, they figured it all out. You know, this was considered to be, and very soon it came to be an idea that this was innate ability. Innate ability. Okay? We're going to get to that. I mean, to me, that assumption is preposterous, but we'll get to it. I want to show you how it works. Okay? Eventually, there was a problem. Okay? Adults, and there was another one. let's go back to the power. Let's say you're always staying a year ahead of your age group. So when let's say we could go down here. If your mental age is 3 and your chronological age is 2, your IQ is 1.5, right? It's 150, right? By the time your mental age is 7 and you're 6, how much is a 6?
116.
Your IQ is 116. If you're 10 and your mental age is 11, your IQ is down to 110. You see what I'm saying? As you went on, people's IQ seemed to dip. Okay? In general, come back to me, it was problematic. And so they wanted to find, okay, another way. Let's go back to the PowerPoint. Boy, this is complicated. Guys back there really working for their money. Okay? So this, and there were other reasons that people didn't like it. It didn't give you enough opportunity to do all kinds of statistical maneuvers that you'll see you can do in the new way. This traditional means, as calculator has been abandoned in favor of using standardized scores based upon the use of standardized deviation. So the driving, and by the way, this approach has overridden everything. Every standardized test, virtually every standardized test, works this way. The IQ is basic thing of the field. Let's go back to the PowerPoint. Okay, the driving force behind all Einstein's tests is the attainment of a normal distribution of scores, the bell curve, and the calculating of standardized deviations therein. Okay, come back to me. Now we need to talk about this. We're going to seem to go far afield. Listen to me closely. It is in the testing that the blinding with science, we talked about blinding with science, right? Didn't we talk about that? Is used the most. Okay, I'll talk about blinding with science. If you take a book that was written by the ancient Greeks, and they identify all kinds of logical fallacies, we talked about logical fallacies, right? And you took a modern book, there wouldn't be too much difference. But there's one thing that has been added, a new way, a logical fallacy or a way to convince people you're right when you're not, and that is called blinding with science. Using all kinds of fancy scientific calculations, scientific formulations, and whoop-de-doo, and people say, oh my God. We talked about the wet paint, huh? Look, if somebody tells you there are 87 trillion stars in our galaxy, and the Earth is 93 million miles away from the sun, our star, and that the Earth has a diameter of so and so many meters, and on, you believe it all. Because if the sign says wet paint, you go like this to test, don't you? Don't lie to me. You go like this, right? Because that's when but when people start giving you this information, and the N score, and this score, and I did my calculations with deviations, and you go like, you must be right, you're a genius. Right? And that's used all the time. Jargon that doesn't mean anything. Your child has an auditory processing problem. Processing problem, can you explain to me what the process is and where it's breaking down? You can't get an answer to that question too well. Oh, we have a Z-score and a D-score and a D-calculation, blah, 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 blah. It bowls people over. I want you to hang in there with me and at least try to get a basic grasp about how this works so you'll understand about how these tests work and how they're used, I'll say it, to victimize children in many cases. We had a guy here, he's since retired. He said to me, you think this stuff is evil, why don't you say it? Okay, I'll say it. We'll get to it. Okay. How many people here are not familiar with the idea of a normal distribution or a bell curve? Is everybody familiar with it? Okay. I'm going to assume that the majority of people who are taking it by television are too, but I'm going to show you one. Let's go to the PowerPoint. That's a normal distribution. It's hard to see. I know it's the best picture I get. If I try to draw one, it looks like I've been drinking for 2 weeks. So, but terrible. That's a normal distribution. As you can see, a normal distribution, this is what it looks like. It's perfectly symmetrical, okay? And its measures of central tendency are all the same. What are the measures of central tendency that we have? Somebody tell me. Push it down. Push it down.
The mean.
Let's go to the overhead. The mean, which is what? What's the mean? What? What is a mean?
The average.
Say it again. The arithmetic, the average, we have other kinds of averages. That's why you use the word. The average of the raw scores, we have other kinds of averages too. We're going to see one in a second. What's another measure of central tendency?
The median.
The median, which is what?
The middle grade.
The middle score, or the middle grade. The middle score. And what else? What's another one? There's one more.
Mode.
The mode, which is what? It's the most common score, right? The most frequent score. One that occurs the most. But see, I'm trying to blind you with science. I had to use the word frequent. The most frequent score. Okay? Now you'll notice, let's go back to the PowerPoint, that on a standard distribution, a normal distribution, this is the mean, it's right in the middle, it's the average. It's the median, it's the score in the middle, and it's the mode, right? Down here is the score on the x-axis, and on the y-axis, which they don't show you, are the number of people getting the score, right? So it's the mean, the median, and the mode. Okay, now, just come back to me, just to be careful, okay? It's important to do that. For instance, there's a town in West Virginia where the mean income was $112,000 a year. This miner earned $14,000, this one earned $12,000, this one earned $7,000, this one earned $18,000, and at the edge of town is the mansion of the guy who owns the mine. He earns $720 million a year, right? Came out to whatever, had $20 million a year, came out, you understand? When you have an extreme outlying score like that, the mean is no good, okay? You need to take the median if you have an extreme outlying score, okay? So, or for instance, let's say I go into this neighborhood and I say, well, we have 3 immigrants from Africa. What's their average height? Okay, and I have 3 Bushmen and a Watusi, right? The Bushmen tend not to get taller than 5 feet tall, and the Watusis, it's rare to find one shorter than 6'5". So if I average it up, I'll get 5'6". Well, 3 of them are much shorter than that, right? So that's the mean. This guy's an outlier. You understand what I'm saying? Or even if I had 10 Bushmen and 1 Watusi, he would screw it up a little because he's more than a foot taller than the tallest one of them. Use the median. The mode, sometimes you want to know what's for various reasons, but a normal distribution gets rid of that. And what happened is a normal distribution was basically a function of the scientific approach. People began to measure things and found out that much of what we have distributes normally. I'll give you an example, okay? Anybody here ever play baseball or softball? You play softball? What positions you play? First, how's your arm? Pretty good? Got a good arm? Okay, come over here. You weren't in the armed forces, were you? Never volunteer, okay? And who doesn't like softball at all? I need a woman. Never played it, doesn't care about it, couldn't care less. Okay. So here's what I'm going to do. If you have a good arm, why are you playing first base?
Because I can stretch.
Okay, tell me your name.
Casey.
Casey.
Jennifer.
Jennifer. Okay. I'm going to get Casey and Jennifer up. Are you better a morning person or an afternoon person?
Morning.
What about you?
Afternoon.
Afternoon. Okay. So I'm going to get up Casey in the morning, and I'm going to say, take this softball you played? Okay, and throw this ball as far as you can. Right? And then we're going to take it, and every morning I'm going to measure how far she threw it. Jennifer, you think you can throw a softball pretty far?
No.
Do you give a damn?
No.
Okay. So, and then I'm going to have Jennifer do it. Now, my guess is, and I'm going to measure it every day, and I'm going to have her do it in the afternoon when she's at the top of her form, right? That the average here is going to be much higher than the average here for how far it goes. Okay? On my 55th birthday, I took out a baseball and I threw it I dug up something that I'd done. I was going through some old papers, and I found some papers how far I had thrown a baseball in high school. And I threw the ball, and one of my sons was in town, he measured it. Holy mackerel, what a difference. After you get to be 40, don't do it anymore, okay? I couldn't believe it. It was a lot less. In any case, so it's possible that her shortest throw will be longer than her longest throw. Casey's shortest will be thrown, right? Sounds to me like it's probably true. Just stand on first base and heave it toward the outfield. But if I do this for a year, don't worry, I'm paying you $100 a day, so it's worth it to you. They're always thinking, a year, are you crazy? After 3 days, get out of my life, right? But I'm paying you a lot of money, right? The throws that I record will distribute normally, okay? Most of her throws will be, how far can you throw? 250 feet, you figure? Okay, 300 feet. Deviating, the shortest throw is 5 feet shorter, and the longest throw is 5 feet longer, because when she's sick, I make her do it, and she gets up when one got pep. And her throw here is, I don't know, 100 feet, let's say. Okay, but still, of course, there's a problem with this, because there's going to be practice here. Especially in the case of the person who doesn't give a damn. You're going to figure things out. But let's say she doesn't, guys. Just let me throw, I don't care. Okay? They're going to distribute normally. I'm going to get, if this is my graph, right, here you're looking at it, this is the low, this is the high, right? So Jennifer's throws are going to be over here on the graph, and Casey's throws are going to be over here on the graph, but they're going to distribute pretty normally. If I were to measure how many hours a night you slept, it would distribute normally. You would have an average, and it would go to the extremes, right? On nights where you're, right? Many things distribute. Okay, give them a big hand. Thank you very much. Good job. Okay, so here, just let me draw that for you. Let me draw that for you. Here, let's go to the overhead, right? Here's the distance, and here's the number of times you threw at the distance. This would be Jennifer's throws, and this would be Casey's throws, but they distribute normally. Most in the middle, and the farther you get to the extreme, away from the middle, the less times you'll have it, okay? If I were to measure the height of all the men in the world, if you get, right, I get something like this, with very few people at the extremes. If I were to measure the height of all the Bushmen, I'd get something like this, and of all the Watusis, I'd get something like this, right? But they would distribute pretty normally. Okay, come back to me. We find that a lot of things distribute normally. Not everything does. Cigarette smoking doesn't distribute normally. People either tend to smoke not at all or smoke a ton. And say, well, it goes from 0 cigarettes to 50 cigarettes. We're up to I don't know, how many cigarettes in a pack? 25? What? 20. Up to 80, right? You don't have too many people smoking 15. You have less people smoking 15 than smoking none. Right? There are some people, I knew one person, she was on the fact she smoked 3 cigarettes a day. Said, I got to have one in the morning. I know, then I can stop because then I'm going to treat myself in the afternoon, and then I can hold out because then I'm going to have one at night. Very unusual. Okay, it doesn't distribute normally. Okay, but there are a lot of things. They once actually watched for years a nesting ground of a flock of robins. And they recorded how many of the chicks survived to fly south for the winter. And they recorded it year after year. Well, some years the cats got lucky. Some years there were storms. Some years they built it in the right place and they didn't get lucky. But sure enough, it distributed normally, the number that survived year after year, right? Things that distribute normally. I once had right, and we often have, right, and usually when we get an outlier, the next year goes back. There was one time I knew somebody, he was involved in criminal justice. I don't think it was the police chief, but he was close, in Wharton. And they had a meeting of all the police chiefs in all the towns around there in Beesville and Wharton and, no, not in Wharton. In Wharton. Okay? Where is it? Victoria. He was in Victoria. Sorry. He was in Victoria, but Wharton and Beesville and everybody else was there in Victoria. And they all claimed, and for some reason, crime was down. They had a very low crime year. They were going to claim credit. He said, you better be careful. Because you've got an outlying year. The odds are it's going to go back to the middle next year, right? Back to the middle. Sure enough. He said, don't claim anything. I'm not claiming anything. I'm just going to claim we're working on. Sure enough, it went back. It was just, freaky things. You know how it is. If you would chart how many accidents there are every day, did you hear today? What a mess. All the highways were full of accidents. There's a day where there's nothing. I hear the report. What's her name? Stella Link. She said, there's nothing out there. I can't believe it. Sure enough, the next day it's back. But if you would do it, it would distribute normally. A lot of things distribute normally. Okay? When statisticians found out about normal distributions, their hearts started to go pitter, 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 and stop to this day. Okay? A particularly normal distribution, if I want to describe, okay, if I want to describe how well did a class do, you have a class of 20 people. Or if I want to describe a population, right, how tall are those people? There are 30 women in the room. How tall are they? What do? I don't say, well, this one's 5'6", this one's 5'2", this one's 4'11", that one's 5'9", or this guy. Johnny's grade was 76, Mary's grade was 83, Billy's grade was 42, Mary's grade was 61. I don't do that. What do? I give the... So how well did that class do? You wouldn't start listing out the 30 grades. What would you say? Say it again? Average. Push it down. Oh, yeah, he said the average. Okay, next time sit by a microphone. Or the mean, I'd give the mean. Okay? And for a long time, people said, oh, a mean, that's good. So how did Miss Jones' class do? The average was 80. How did Miss Brown's class do? The average was 40. Well, Miss Jones. But there was a problem. There was a problem. Say, how did Miss Brown's class do? Well, the average was 78. How did Miss Green's class do? The average was 78. But here are the scores in Miss Brown's class. 78, 77, 79, 80, 76, 77, 78, 77, 78, 78, 78, right? And it came out to 78. Is that what I said? The average was 78, right? Here's Miss Green's class. 42, 100, 79, 56, 98, 80, 12, 107 because of extra credit, 96, right, et cetera, came out to 78. Well, that didn't work. People realize you got to be careful about averages. Or as one statistician told me, my head is in the oven is turned on. My head is in the oven. My feet are in the freezer. On the average, I'm okay. Right? Now, you can't hold me to this, but I believe, I say this every class, I put it on tape, but I believe I'm right. The average high temperature in Amarillo for a year is roughly the same as the average high temperature in Seattle. Anybody ever been to Amarillo? Yeah? Anybody from Amarillo? Oh, man. Who's been to Amarillo in the summer? Describe Amarillo in the summer in one word.
Horrible.
The temperature in one word.
Hell.
Yeah, it's hot. I mean hot. It's a little drier than I was there in one summer. Oh, it's dry heat. Oh, really? Somebody's blowing a fan in my face and I'm collapsing here from dehydration. It's hot. Anybody ever been to Amarillo in the winter? No kidding. And? Pass through? Pass through, he said. And? It's cold.
It's in the 30s.
In the 30s. It's cold. It gets colder than that. As a matter of fact, my daughter was going to work in Denver. And so we go to AAA, and they said, they gave us a route up through Kansas and over. So my wife was looking at the map. She said, wait a minute, why can't we just go up, through Dallas and through Wichita Falls and through Amarillo up to Denver? It's much shorter. I said, yeah, you're right. But it's the pass of snowed in Amarillo, you're going to be stuck, right? So they risked it. They did it, right? They had a weather forecast for 3 days, and they got through that. But it's cold. So if you have if you have a day of 0 and a day of 100 and 2 days of 50, you get the same average, 50, right? And if a farmer is farming in near Seattle, Washington, and is told, oh, go to Amarillo, it's the same average temperature, that farmer is in for one big surprise, okay? So people began to say, we need to have some kind of a measure of variance around it, right? The scores in the second class, I think there was Ms. Green's class, right, vary, or they deviate much more from the mean, from the arithmetic average, than the other one. Both terms I use, variance and standard, and a deviation. They actually both have mathematical meaning. So what they said was, okay, let's get some kind of measure of how much the scores deviate. So what they decided to do is to take a different average. Not an arithmetic average, but the average of the deviations. So here's what they said. I'll show you how it works. They said, look, let's say we have, our average is 80. I'll make it easy. Let's see how much each score deviates from the mean. So we have 78, 79, 82. This is not a normal distribution, but you get the idea, right? 81, 80, okay? And we'll subtract each score from the mean, right? We'll see how much it deviates, okay? Got it? So we're going to, and then we'll take the average. So this is 2, right? This is 1, this is 2, this is 1, this is 0, right? So in other words, we'll take the mean, that is the arithmetic for the mean. We'll subtract each score from it, okay? And then we'll just take the average by the number of scores, right? And in the class, where the scores were, 100, 34, yeah, let's do it on the other side. Wait, let me erase this. In the class where the scores were 100, I know what I'm doing wrong. 100 and 34, well, this deviates 20 points, right? And this deviates how many? 46 points. You add that up and take the average, you're going to get a much bigger number, right? See what I'm saying? There's only one little, okay. You see what I'm saying? We're going to take look, this is the formula. This means sum. Sum all the scores here. Let me, don't do anything yet, okay? Here. Here's what you need to do. Here's the formula. See, don't get blinded here don't get blinded by science, by fancy stuff. Wait, let me show it to you. Here, let me show it to you. I don't have this quite right because I was piddling and I didn't know how to use the computer, but wait a minute, I'll get there. Okay, let's just go to the overhead. To the PowerPoint, to the PowerPoint. Okay? This is the formula. This is the formula for okay, here's the formula. The mean equals the sum of the x over n. You've been doing this since 5th grade, right? What you do to get a formula is, this is the Greek sigma, it means sum, right? You take all the scores, you divide it by the number of the scores, and you get the arithmetic average, right? Right? Add all the scores, divide by the number of scores. So let's go back to the overhead. So instead of just adding the raw scores, you're adding this different scores and getting the average. You see what I'm saying? Okay, there's only one little problem. You see, 80 take away 78 is 2. 80 take away 79 is 1. 80 take away 82 is minus 2. 80 take away 1 is minus 1. 80 take away 8 is 0, and this all sums to 0. See? Get what I'm saying? Okay, come back to me. As a matter of fact, come back to me. if you do this every time, it will sum to 0. That's how statisticians define an average, right? If you do that for any test, if you subtract the scores from there with the plus and the minus signs, then they'll always come out to 0. But they didn't want to desert this. So at first they tried, come back here, this trick. What do you call this? I forgot. That absolute value, right? The absolute value, that is one, right? Try the absolute values. Just make them all pluses. But in the end, what they decided to do, here's my formula, is say, let's square it. Okay? You see? So this was a minus 20, and this was a plus 46, right? Let's just square each one. So this will be a 4. Here, you see that? Here. This will be, we'll square this, it'll be 4. We'll square this, it'll be 1. We'll square this, it'll be 4. We'll square this, it'll be 400. We'll square, I don't know what 46 squared is. We'll square them, right? That's what they decided to do. Come back to me? Okay. Then we'll add up, what?
2116.
2116, 46 squared, right? He did it in his head just like that. He ran with his finger. Okay? We'll just square it. You got it? We'll just square them, then we'll add that up. So in other words, and that we'll just add, and we'll get an average of the squared differences. When you square it, right, a minus turns into a plus, right? And that is actually called the variance. That's called the variance. The trouble with that is you've got scores from 0 to 100, and how much was 46 squared?
2116.
You're starting to get huge numbers, 2116. It ticked people off. He said, you know what? I mean, we're going to get an average. The variance is 89, right? In the second class. The variance in the first class is 3. You understand what I'm saying? You're getting an average. It's a number you're getting. You're averaging these differences. Sometimes, though, you get variances of, you'd get a variance of 2116. Or you get variances, you get huge numbers. People say, you know what? Since we squared every number, let's just take the square root of the variance. So if the variance comes out 16, let's take the square root and get it back to 4. And that's called the standard deviation. Let's go over here again. Okay. The standard deviation equals the square root of the variance. You got it? If my variance comes out 100, I'm going to make my standard deviation 10. See what I'm saying? And if my standard deviation comes out 144, the variance comes out 140, that's what worried people. I got scores from 0 to 100, and my variance is 144. This is driving me nuts. Let's just take the square root of that number and call it 12, right? Of course, it never comes out perfect, so it's always some decimal. You understand what I'm saying? And that way, I can know these two, that the average temperature in Seattle is 78 with a variance of 3 degrees, with a standard deviation of 3 degrees. And the average temperature in Amarillo is 78 with a standard deviation of 14 degrees. Then I know there's a much bigger deviation. It's going to be a lot hotter and colder than it is in Seattle. And that's more or less true. You understand what I'm saying? The average, and by the way, the average score in this class was 77 with a deviation, a standard deviation of 3 points. And the average score in the other class was 77 with the average standard deviation of 12 points. Well, that gives me a different job to do. The first class, I'm going to try to move them all up together. The second class, it's obvious. Just from here and there, I got students way below the average, way above the average. I got abilities all over the place. I have a different problem. Right? Same thing in counseling. Give personality tests. Well, on the average, everybody in this place is more or less neurotic. Well, in one place, everybody is neurotic. In the other place, you've got neurotics, healthy people, and people who are psychopathic. Well, I got a different job on my hands in the 2 hospitals, right? Or with my 2 patient loads. So, if I have a scale of mental health from perfectly healthy to flipped out psychotic, right? So, I know it's not nice to say flipped out, but I got that from a therapist. One day I'll tell you about my schizophrenic I used to work with. So all of this, so what happened is that this made statisticians very happy with themselves. They had a very good way of describing with two numbers general populations. The exact formula for the standard deviation doesn't matter, but you get the point, right? Then something happened. And standard deviations have come to fulfill a role where the deviation almost doesn't matter to people. What happened is, let's go back to the PowerPoint. I know it's hard to see, but, and the colors are different on the screen than they are on my, that I put on, but that's how it works. Okay? They find out that provided, I'm yelling because it's important, provided that you have a normal distribution, 34% of your scores will be between the score between the mean and one standard deviation above the mean. So if your average is 80 and your standard deviation is 4, 34% of the scores will be between 80 and 84, 34.13. You don't have to worry about, because the standard deviation is always 4.2793, right? And the scores are either 84 or 85. And 34% of your scores will be between 76 and 80. You understand what I'm saying? Here. Let's go here. Okay? Let's go to the overhead. Let's say you work it and you're playing around and your mean, your average comes out to be 82 on a test. Okay? And you play around, you get the average of the difference, and your standard deviation gets to be is 6. 34% of the scores will be between 82 and 86, because I'm adding the 6 points, right? Between 82 and 88, because I'm adding the 6 points. That's a score that is plus 1 standard deviation above the mean. You understand why? If you don't, ask me, because it just drove me nuts when I was studying it. Now it seems so easy to me, but it drove me nuts. If you don't understand, ask me. Who wants me to explain again? And 34% of the score is actually 34.13. 34% of the scores will be between, help me here, 82, between 76, is that right? And 82, right? This is 6 points below 82, right? 1 standard deviation below. You see what I'm saying? Who doesn't see? Tell me, I didn't see. You all see that? I don't believe it. Everybody here is smarter than I am. Go ahead. You don't get it? Okay. Okay, here's what happened. I took my scores in the class, okay? And I found out that the average was 82. Then I did this calculation here, okay? Okay, I got the variance, and then I took the standard deviation, okay? I got the standard deviation. It just turned out to be 6. My standard deviation turned out to be 6. So let's go to the overhead, to the PowerPoint. It turns out, as long as I have a normal distribution, whatever my mean is, whatever my standard deviation is, 34% of the scores are between the score that's the mean, that's the average, which is 82, and the score that's one standard deviation above the average. It was 6, right? So it's 6 points above the average is 88. Okay? You understand what I'm saying? Look, come back to me. Come back to me if you can. This is not something statisticians cooked up. It's just the way it is. Somebody with an anal compulsive personality that we'll get to, with time on her or his hands, went and counted over and over. That's how it came out. Let me give me an example here. Look. Remember this? C equals pi d. Remember that? The circumference of a circle equals pi times its diameter, right? Okay, now we're going to take a vote. Come back to me. How many people are convinced that pi is something math teachers made up to torture you? 1.14, what is this? 2 pi r, right? The area of a circle is pi r squared. All that. What is this pi? Come back here and I'll show you what pi is. Okay? Let's divide both sides of these equations by d. Okay? This cancels out. What I get is C over D equals pi. Okay? This is a universal constant. Whenever you have any circle, you take its circumference, you divide it by its diameter, and that's the answer you get. Believe me, I wish it weren't that way, but that's how it is. So, come back to me. If I have, one of those guys sitting in the mall, he said, I'll write your whole family history on a grain of rice, that stuff, right? He comes and on this grain of rice, he draws the smallest circle he can. I should say she, but all the other people I know are he's. Then you take an astronaut and say, go out into space and fly in a circle that has a circumference of 1,000,000 miles. And I take those two circles, and I take the circumference of each circle and divide it by its own diameter, I get pi. That's just how it is. How many people hated this stuff in school? Who hated it, right? Much to our upset, those of us who hated it. Much to our depression and misery. But that's how it is. Likewise here, for reasons that just the way it is, whenever you take a normal distribution and do it, let's go back here, okay? This is rounded off. Can you see this on the screen, or it's rough? We'll give it a shot. Roughly 34% of the scores, 34.13% of the scores, usually rounded off to 34, fall between whatever the mean is and 1 standard deviation. 13.59% of the scores, usually rounded off to 14, fall between 1 standard deviation and 2 standard deviations. So in our case, it would be between 86 and 92, right? And a roughly 2.14% of the scores fall between 2 and 3, okay? And likewise this way, okay? If you add this up, you'll see it comes out to 99, and about 0.5% of the scores are higher than 3 standard deviations, and 0.5% are lower than 3 standard deviations, okay? Come back to me. You don't have to understand it exactly, but you understand that's just the way it works. All of a sudden, bells go off. Look, everyone here taking the course is 10 years old. Everyone taking the course on television is 12 years old. Everyone taking the course, let's just say, everyone who's taking the course from purchasing the CD or the tape, the DVD or the tape, is, what do we have, 10, 12, is 8 years old. Now, I don't care. I can give you all the same test. I got to try hard to get the items to test to distribute normally for all your ages, and just compare you to your own age by how many standard deviations you are above or below the norm. So, tell me your name.
Heather.
Heather got exactly the norm. For 12-year-olds, we're 12 in here, right? Samantha, who purchased the tape, 8-year-olds, got the norm for her age group. And Roberta, today's a she day, who got it from the people who are watching it on TV, got exactly the norm for her age group. They all have the same IQ. Now, this is no small task, my friends, because I got to get all the answers to these questions distribute normally. If I find out, for 12-year-olds on this particular test, they all got, there's subtests to this, they all got all the answers right, I got to change them. It's not easy to do because it has to distribute normally across all the age groups. So, I'm going to measure Heather, how many standard deviations below the mean she was. Her IQ was 0, right? And so are the other two people's IQ 0. Does anyone know what that's called? What kind of score that is? A real score of how many standard deviations above or below the mean you are.
A z-score.
A z-score, good. Who's never heard of a z-score before? Who's heard of one and the thought of it makes you ill? Now you know what it is. A z-score is simply a measure. So if, tell me your name?
Oscar.
Oscar. If Oscar's score was 1 standard deviation, Oscar is 8, and his score was 1 standard deviation above the mean for 8-year-olds, his score is +1. But Amir, I remember your name, just because I have a friend named Amir. Okay, Amir's score is about a third of it. It's 6 points, and the standard deviation is 12 points, and he's 2 points below. So he's like 0.2 standard deviations below the mean. So his IQ is minus 0.2, right? See what happened? Well, first of all, what's wrong with it? What are the two things in the score of minus 0.2 that the people who didn't like math that you cannot stand? The negative number and the negative number minus 0.2. What else? The stinking decimal. When I say it, it makes me sick. Right? Besides, I can't go to Heather's mother. How old were you, Heather? No. 9. You were 9, right? She was not. No, Heather's 9. I made you a different person now. You're out of the group. Heather's 9. And I can't say to her, what's your last name?
It's Hughes.
What?
Hughes?
Hughes? I can't say, Mr. Hughes, your daughter's IQ was 100, but we've changed our scoring system slightly, and now it's 0. I can't do that. So what happened is people began to play games with this IQ thing, with this normal distribution thing, to try to get scores that got rid of decimals, that got rid of right? Some of you know them. SAT and GRE scores. Who took the GRE? A lot of you. You took the MAT? Oh, yeah, a few of you were. I don't know, that's scored a different way, but our scores based on standard deviations above and below the mean, kind of, sort of. IQ is based on that. Percentiles are based on that. All of it is based on scores, and all of it means that you have to have a test that gives you a normal distribution. So the question as to if an item on an IQ test, what is this item doing here? If you go to Piaget and say, why did you ask this question? He'll tell you, because this is what my theory says. What do IQ people tell you? Why do I ask a question, this question, and not another question? What's the answer? Because that question gives me a normal distribution. The answer to any question about the IQ test is the S word, not that one. Statistics. Why are you asking this problem instead of a similar problem? Because that's the one that gave me the normal distribution. I don't want to give it away, because I'm going to ask some questions about what's on an IQ test. I think you're going to be a little flabbergasted by it, and I hope you are. So next time we're going to look into different kinds of scores with normal distribution and ultimately how the IQ test works, what they decided to do, so that IQs basically came out the same. So that I don't have to go to someone and say, your kid's IQ is minus 0.3. Or your kid used to have 140 IQ, now it's 2. People didn't like that. So next week we're going to go into this a little. We're going to show it, and then we're going to start, after that, we're going to start looking at IQ tests, standardized achievement tests, the relationship between them, and how they have burdened our educational system with label after label after label. All right, I'll see you next time.